Welcome to the discussion. We are representing a question that was done in KCSE 2022, Paper 1, Section B, question number 19, a question from gradients and equations of straight lines. The question we have reads, a triangle ABC is a right-angled triangle at A. The vertices of the triangle are 1, -2, 5, 4, and of course C with coordinates MN. So we can begin by sketching this type of triangle here. This is the triangle we have, and we are told it is right angled at point A with coordinates 1, -2. We have B with coordinates 5, 4, and of course C, we have been told the coordinates are MN. Having sketched that diagram, we can now look at the question. The equation of line BC, has been given is 5y minus x being equal to 15. From there, in form of y is equals to mx plus c, we are going to have this equation as 5y being equal to, we move x to the other side, it becomes positive, plus 15. We divide all through by 5. Y is going to be equal to a fifth x plus of course 3. That is not what the question requires us to do. We are required to determine the equation of line AC, that is AC, in form of ax plus by plus c is equals to 0, where a, b, and c are integers. From this question, you realize we cannot be able to work out the equation of AC because of the unknowns, and therefore we are going to begin by looking at the gradients of AB, because AC and AB are perpendicular. So the gradient of AB, remember gradient is equals to change in y over change in x. So the value of y here is going to be 4 minus 2, which is y at this point A, minus gives us plus, divided by 5, minus 1, and this one is going to give us 6 out of 4, translating to 3 out of 2. Having gotten the gradient, we know for perpendicular lines, the product of their gradients is equal to -1. That means m1 times m2 for perpendicular lines gives us -1. Assuming the line of the gradient of AB is 3 out of 2, the gradient of AC is going to be m2. This gives us -1, and therefore we can easily conclude that m2 is going to be -2 out of 3. Once we have the gradient of AC, we can be able now to get the equation by taking the coordinates of C, that is M, N, and of course that of A, which is 1, -2. Then of course find the equation, because we need the equation of AC, and in this case we can take the value of y, which is N at point C, minus 2 gives us plus 2, divided by M, minus 1, and this one translates to the gradient, which is 2 out of 3. If you cross multiply, we are going to have 3 times n, giving us 3n, then 3 times 2 giving us +6, being equal to -2 times m gives us -2m. Then of course -2 times -1 gives us +2. From there we collect the like terms. We are going to have 3n plus 2m being equal to +2 remains here, then we minus 6, we move this to the other side. But remember, in terms of the coordinates given. M represents x and n y, and therefore we begin with m. We are going to have 2m plus 3n, then of course being equal to -4. Remember, we are supposed to present our equation of AC in form of ax plus by plus c is equal to 0, and therefore we are going to assume that m stands for x, n stands for y, and therefore we are going to have 2x plus of course 3, n stands for y. We move this to this other side, it becomes a positive, and this we equate to 0, and that becomes the equation of line AC. Once we have done that, we can be able to move now. We can be able to move to Roman 2. So Roman 2, we need the coordinates of point C, which is the value of m and n. And since we have the equation for AC, which is 2x plus 3y, we can move this c to the other side so that we form a simultaneous equation. And of course we have the equation of BC. The equation of BC, we have already gotten it. In fact, it was given as 5y minus x. So we begin with minus x plus 5y. We equate this to 15. This is actually BC. The reason why we are using AC and BC is because C is a common point between the two lines, and therefore we call it a point of intersection. We solve this using elimination method. This is 5, we can multiply with equation 1, then 3 equation 2. Then from there we proceed. 5 times 2x, you get 10x. 3y times 5, you get plus 15y, being equal to -4 times 5, which is minus 20. Equation 2, we have minus x times 3, you get minus 3x, plus 5y times 3, you get 15y, and this becomes equal to 45. Once we have done that, under elimination we subtract the 2, but this part that is similar cancels. We remain with 10x minus minus 3, giving us 13x, and this becomes equal to minus 20 minus 45 gives us -65. From there, if you divide both sides by 13, x is going to be equal to -5. Once we get the value of x, we can use equation, for example, 1, which is 2x plus 3y being equal to -4. We know the value of x is -5, so -5 times 2 gives us -10, plus 3y being equal to -4. Then of course if we take this negative to the other side, it becomes a plus. 3y is equal to 6. Divide both sides by 3, y becomes 2 positive. Once we have the value of x and y, we can simply write them as a pair of points. M stands for x, and x is -5. N stands for y, and y is 2, and that becomes the answer to that particular question. Remember to subscribe and also help us to share the link. We are moving to part B. A line passes through point A and is parallel to line BC. Determine the x-intercept of the line. We know at x-intercept the value of y is always 0. So we are told a line passes through point A and is parallel to BC. We had already drawn this kind of sketch where we have A, we have B, we have also C. We have been given the equation of C. which we expressed in form of y is equals to mx plus c, as y being equal to a fifth x plus of course 3. Then we are told there is a line that moves this way and it touches point A, and this particular line is parallel to BC. So we know parallel lines have equal gradients. A line passes through a point A, so we can assume that this line goes through point A and also through another point, for example Q, with coordinates, for example xy. Since we know that the two lines are parallel, we know for parallel lines m1 is equals to m2, and their gradient is actually going to be a fifth. Once we know that, we can now go down and of course take the point A, which is 1, -2. We also take another arbitrary point along this line, which is xy, and of course the gradient is 1/5. We get the equation first before getting the x-intercept. So what we are going to do here, we get the gradient again. To get the gradient is changing, we have a change in x. This is going to be y minus -2, which is +2, divided by x minus 1, and this one is going to be a fifth. So we proceed and cross multiply. 5 times y, you get 5y, plus 2 times 5 gives us 10, and this one is going to be 1 times x is x. 1 times -1 gives us -1. Collecting the like terms, we are going to have 5y being equal to x minus 11, because if we take 10 to this other side, it becomes a negative. Divide both sides by 5, all through. This and this goes, and our y is going to be a fifth x, plus of course that is minus 11/5. From there we are good to go. Remember, at x-intercept, the value of y is 0, and therefore we replace y with 0. We are going to have 1/5x being equal to, that is minus 11/5. Then we move this to this other side, we are going to have a fifth x being equal to 11/5. Since 5 is common, we can easily drop it and say x is 11, because even if you cross multiply by 5, we are going to remain with x as 11, and this becomes the x-intercept of the line. Thank you for watching and welcome to this channel. And in case you're watching this channel for the first time, please take a second or two, click the subscribe button so that anytime we publish a video like this, you'll automatically be given a notification.